Determine the Fourier transform of x of t equal to e raised to minus 3 mod of t. So first we write the given signal. What is given? Given signal is x of t is equal to e raised to minus 3 of t. Now we will decide the nature of signal by putting the different values of t. So for t is equal to 0, the equation becomes x of 0 is equal to e raised to minus 3 mod of 0, it is e raised to 0 is 1. Now for the negative values of t, for t is equal to minus 1, here we directly write the answer. It is x of t, or we can write x of minus 1 is equal to e raised to minus 3. For t is equal to minus 2, x of minus 2 is equal to e raised to minus 6, 3 into 2. T is equal to for minus 3, it is x of minus 3 is to minus 9. Now for the positive values of t, for t is equal to 1, t equal to 2, t is equal to 3. So x of 1, x of 2 and x of 3. So we get okay, these values are okay, just minus 9. Now we draw the diagram. So the nature of the signal is 0, 1, 2, 3, minus 1. So it is e raised to minus 3, minus 6, e raised to minus 9. Sorry. So this is the nature of signal. Now it is double-sided exponential pulse. So mathematically we can write this equation as x of t is equal to e raised to plus 3t u of minus t plus e raised to minus 3t u of t. So x of f is equal to 1 by 3 minus j2 pi f plus j2 pi f plus 3. So we multiply it and here I write direct final answer 6 plus 9 2 pi f square. So this is the answer. Now the next problem is obtain the Fourier transform of x of t is equal to d by dt of e raised to minus 8t u of t, given that e raised to minus of Now the next is the solution for this. So what is given? Given is that x of t is equal to d by dt of e raised to minus 80 u of t. Now we have e raised to minus 80 ut Fourier transform 1 by j2 pi f plus e. Now according to the differentiation in time property, we write here according to differentiation in time property, d by dt of x of t, this is j2 pi f x of f. So Fourier transform d by dt of is to minus 80 u of t, j2 pi f by plus a. Now the next problem is determine Fourier transform of, first is x of t is equal to d by dt of e raised to minus 2t u of t, and second x of t by 2 cos of omega 0 t. Now first we solve the first problem. So what is given in first? X of t is d by dt of minus 2t u of t. Now according to differentiation property, so d by dt of x of t Fourier transform, this is j2 pi f into x of f. So consider let x of t is equal to e raised to t u of t. Therefore x of f is equal to 1 by 2 pi f plus 2. So Fourier transform of d by dt of this equation is so this is the Fourier transform of equation d by dt. Now second problem is according to modulation theorem. We have to use here modulation theorem. According to modulation theorem, so f of x of t cos omega 0 t equal to half x of omega minus omega 0 plus half x of omega plus omega 0. Now consider let x of t is equal to rectangular of t by 2. Now we have some standard identity. What is standard identity? We have standard identity as a by 2 of rectangular of t by tau, it is a sinc of f of tau. We have the standard identity, so we will use this here. So xf is equal to sinc of 2 omega. So we can write this equation f of rectangular of, what is x of t now? It is t by 2 of cos omega 0 t. So it is equal to half sinc of c into 2 omega minus omega 0 plus half sinc of 2 into omega plus omega 0. We just replace these values here. Now the next problem is fourth problem. Find Fourier transform of d by dt of e raised to minus of mod of t. So according to differentiation in time property, so Fourier transform of d by dt of x of t is equal to j2 pi f xf or j omega x of omega. So we can write Fourier transform of d by dt of e raised to minus of, what is x of t here? It is this function. So it is j2 pi f into 2 by 4 pi f square plus 1. We can write j 4 pi f by 4 pi f square plus 1. So this is a Fourier transform of given function. Now next problem is find Fourier transform of x of t equal to sin omega 0 t u of t. So we have to find this Fourier transform. So according to Euler's identity, what is sin theta? Sin theta is equal to e raised to j theta minus e raised to minus j theta divided by 2j. So we can write sin omega 0 t is, here theta is omega 0 t. So it is e raised to j omega 0 t minus to minus j omega 0 t divided by 2j. So x of t is equal to e raised to j omega 0 t minus e raised to minus j omega 0 t by 2j into u of t. So we can write this function as x of t is equal to 1 by 2j e raised to j omega 0 t u of t minus e raised to omega 0 t u of t. This is equation number 1. Now we have the standard Fourier transform pair. So what is that standard Fourier transform pair? As u of t, Fourier transform of this is 1 by j 2 pi f or 1 by j omega. Now according to frequency shifting property, what is that property? E raised to j omega 0 t u of t, Fourier transform this is 1 by j into omega minus omega 0, and e raised to minus j omega 0 t u of t, Fourier transform this is 1 by j into omega plus omega 0. So these are the standard function. So Fourier transform of equation 1 becomes now x of f is equal to 1 by 2j, 1 by j into omega minus omega 0 minus 1 by j into omega plus omega 0. Okay, now here we can write this function as it is 1 by j omega minus j omega 0, 1 by, we multiply j inside the bracket omega 0. So we consider this term as a, this is as b, this is again a, and it is b. So it is a minus b, a plus b. So it becomes a square minus b square. We just consider this, and so x of f becomes, we multiply all the terms, j omega plus j omega 0 minus j omega plus j omega 0, and the denominator terms becomes a square minus b square, that is j omega square minus j omega 0 square. Okay, so here these two terms get cancelled and equation becomes xf is equal to, okay, it is 1 by 2j, it is 1 by 2j, no, wait, and it is 2j omega 0 divided by j square omega square minus j square omega 0 square. Okay, now here 2j get cancelled, so again equation becomes omega 0 divided by minus omega 0 square plus omega, minus omega square plus omega 0 square is omega 0 divided by omega 0 square minus omega square, as 2j get cancelled. Therefore omega 0 t u of t Fourier transform of this function is omega 0 divided by omega 0 square minus omega square. This is the Fourier transform of that function. Now the next problem is find Fourier transform of x of t is equal to cos omega 0 t u of t. So according to Euler's identity, cos theta is equal to e raised to j theta plus e raised to minus j theta divided by 2. So we can write cos of omega 0 t is equal to e raised to j omega 0 t plus e raised to minus j omega 0 t divided by 2. So we can write the function x of t is equal to cos omega 0 t u t equal to half into bracket e raised to j omega 0 t ut plus e raised to minus j omega 0 t u of t. This is equation number 1. Now we have some standard formulae that we have ut Fourier transform of u of t is 1 by j 2 pi f or 1 by j omega. Okay, so this function we already have. Now using frequency shifting property, we write here using frequency shifting property, e raised to j omega 0 t ut Fourier transform of this is 1 by j omega minus omega 0, and e raised to minus j omega 0 t ut Fourier transform of this is 1 by j into omega plus omega 0. So these property we already have. Now we can write taking the Fourier transform equation 1. Taking Fourier transform of equation 1. So we can write this equation 1 as x of f is equal to half into bracket 1 by j into omega minus omega 0 plus j into omega plus omega 0. Now we solve this problem like the previous problem, and here I directly write the answer 1 by 2 into 2j omega divided by minus omega square plus omega 0 square. We can write j omega divided by omega 0 square minus omega square. So this is the answer.